What's the medium that this is going to be travelling through exactly?
Right, exactly. No one knows. I mean,
well, there is a claim about what. Hold on, it's going into the sky, right? Is there not an on the table claim about what the sky is? The medium.
Vacuum.
I mean, to a certain extent.
Somebody got it. Hold on, Fenris. Who said that?
Sure.
Sky vacuum.
Oh, that's a bit of a problem, because the claimed medium that they're taking this measurement through, when they presuppose the lights are at vast distances because they're starting with the spherical Earth, the medium that it's travelling through is a violation of a natural law. So, like any travel to the moon or satellites in orbit presupposed again around a spherical Earth, of course, well, all of those things are taking place in a medium that doesn't exist. So if they're claiming they know the distance and the time it would take to get back on this presupposed journey at vast distances, then they're going to be able to verify that the medium's a vacuum, are they? A violation of a natural... No, they're not, no. So, like everything that takes place in Narnia, including this measurement, with the presupposed duration of travel and when it's going to come back, when they look through that audio garbage on their screens, the visual garbage that they see, the noise and interference, they're going to say, oh, that's the return signal, exactly when we thought it would come back, when we presuppose these lights are at vast distances. Through the medium of a vacuum.
Basically, under the title of Venus or Bust, it says, on the 10th and 12th of Feb, 58, the radar was pointed to detect Venus and then some 45 million kilometers away. The radar signals took about 5 minutes to travel the round-trip distance. In contrast, John DeWitt's signals went to the moon and back to Fort Monmouth, New Jersey in about 2.5 seconds. Of the 5 runs made, only 4 of the digital recordings had few enough tape blemishes that could easily be edited and run through the computer. 2 of the 4 runs, one from each day, showed no evidence of radar returns. The others had 1 peak each. Price recalled, when we saw the peaks, we felt very blessed. It was not absolutely clear, however, that the 2 peaks really were echoes. Green explained, quote, we looked into our soul about whether we dared go public with this news. Bob was the only guy, Bob from JPL, this is not Jodrell Bank, this is JPL in America. Bob from JPL was the only guy that really stayed with it to the end. He had convinced himself that he'd seen the echoes, and he had convinced me that he'd seen it. Management asked us to have a consultant look at our results, and we did. Thomas Gold of Cornell University looked at their peaks and said, yes, I think you should publish this. Green and Price then published their findings in March the 20th, 1959 issue of Science, the Journal of American Association for the Advancement of Science, 13 months after their observations in February 1958. The problem with it is, when they built the Jodrell Bank telescope, the technicians and the scientists that built it, basically they couldn't conclude what they were receiving when they got this ping bounce back, because it was full of static noise. There was noise of the environment in which they're in, like traffic and bees flying by and all that kind of stuff. So what they're perceiving, they couldn't come to an agreement. It was only when they sent it over to JPL, which is basically NASA, and JPL said, yes, that's the ping reflection from Venus. That's when they all jumped on the bandwagon. But look at how it describes Bob from JPL. It says, he had convinced himself that he'd seen it, right? And had convinced me that he'd seen it. But that doesn't mean that it was true what he was looking at. So in other words, he's looking at like seismology kind of graph type kind of things. And he's going, yeah, I think that's it. And he's convinced himself that he's looking at a reflection of reality. But the reality is, you can't tell. This is not conclusive evidence to prove that this is what he said, because he convinced himself that he'd seen it. Not that he'd seen it, that he'd convinced himself. And I'm like, that seems to be really weirdly worded for something that's supposed to be as majestic as measuring the distance to Venus with a ping reflection. You shouldn't need to be convinced yourself that that's what you've seen. It should be obvious. It's either a ping or it's not. And he needed to convince himself that it was. And my position is, well, what if Venus isn't that far away and the ping reflection didn't take 6.5 seconds and it was only 5.2 seconds or 1.6 seconds, and they're looking completely at the wrong direction or in the wrong time slot for where this ping reflection should be? And if the moon was 2.5, what happens if Venus is only like, I don't know, 8 seconds away or 2 seconds away or 7 seconds? Who knows? My point is, it's not persuasive enough for me to think that this is a legitimate experiment, because if it needs somebody to persuade himself in JPL, that's NASA, and then go back to England and tell all the other people that, yeah, we think it is it, and then everybody then jumps on it, how persuasive is that overall? For me, I don't think that's persuasive at all.
Well, we ask for scientific evidence of things, and what we've got is a guy from JPL saying, "Oh yeah, it's definitely that," and then convincing people. What about empirical scientific data? Oh, we're brushing past that with this crap where we bounce stuff off lights in the sky, are we? We're deciding how long it's going to take and then looking in that particular time frame, are we? Oh, right, this sounds like zealotry and religion as opposed to science. This is pseudoscience. Like with everything they claim, it will start with the presupposition of Earth being spherical. That has resulted in the stars being pushed out to these astronomical distances by presupposing an R value, taking these measurements. And then when you fast forward to modern times and they say, oh yeah, we're measuring it with bouncing stuff off it. Oh really? And how do you know when the return signal is going to come? Oh, well, because it's all based on our heliocentric model of the world, with these stars at these vast distances that we've presupposed. Because they've got to be if Earth's a sphere. That's their explanation.